Hi everyone! Today I'll be talking to you guys about error detection and error correction. These two are called error controls. There are techniques which are used to send digital data through unreliable communication channels. We know that communication channels are subject to noise and are also subject to other interruptions. So we need to find ways in order to detect these errors and also correct them. So first of all, I'll be talking to you guys about error detection. Error detection is done through redundancy check. Redundancy check is simply the streaming of data bits in order to check for an error. And an example of this technique is parity check, which is also known as a vertical redundancy check. Okay, so then we move on to speaking about error correction. Error correction can be done in multiple of ways, but then the simplest of ways is through the flipping of bits, and this process is called the Hamming code process. So there's a streaming of redundant bits which is sent or transmitted to a receiver, and then the receiver is able to detect through a flipping bit where the error has taken place. So that is it for error correction and error detection.
Hamming code is a way that we use to detect errors and correct it. So now we are going to create a data words including parity bits. All bits position that are powers of 2 are our parity bits. Okay, so we will be having P1, P2, P4 and P8 as our data parity bits. So how to use the P1 to check errors? So in P1, parity bits 1, we will check every bit by skipping a bit. So we check one bit and then we skip another bit, and then we check the bit and we skip another bit. Okay, for the second parity bit, we will be checking the 2 bits and then we skip another 2 bit, and so on. Okay, for the 4th bits, we will be checking 4 data bits, and then we will skip 4 bits after that. We'll check for 8 bits and then we skip 8 bits. Alright, so how to fix the bad bit? So let's say if we have the error at the D10, we will try to find it by using the parity bits. So let's say for the first bit, if we add all the bits together, if we get the even bit at the P1, it means that we will have 0 at the first bit. If we count the 1 and then we got an odd number, so we will put 1 at the first parity bit. So we will repeat all this procedure to the other parity bits, and then so we can detect that parity 2 and parity 8 have an error, have errors inside the bits. So we just need to add 2 plus 8 and we will get 10. 10 represent the position of the bit that will be the error. So we will know that data bits in B10 is the error in our data.
And I'm here to tell you about a parity bit. A parity bit or check bit is a bit added to a string or binary code to ensure that the total number of 1 bits in the string is even or odd. Parity bits are used as the simplest form of error detecting codes. Parity for a given set of bits, the occurrences of bits whose value is 1 is counted. If that count is odd, the parity bit value is set to 1, making the total count of occurrences of 1s in the whole set, including parity bit, an even number. If the count of 1s in a given set of bits is already even, the parity bit's value is 1. In the case of odd parity, the coding is reversed. For a given set of bits, if the count of bits with a value of 1 is even, the parity bit value is set to 1, making the total count of ones in the whole set, including the parity bit, an odd number. If the count of bits with a value of 1 is odd, the count is already odd, so the parity bit's value is 0.
Hello everybody, my name is Hakim and Zulkarnain. Today I'm going to present about the second dimensional parity check. So there's two things you need to know. First is they have like the column parodies, which is here, okay. And then there's the row parodies. Okay, the column is like to represent the y-axis, and the row parodies is to represent the x-axis. Yeah. So when there's one error, you can detect two parodies, and if there's two errors, you can detect also two parodies. And when there's 3 errors, you can detect 4 parodies, and when there's 4 errors, you cannot detect. You cannot detect. Okay. So that's it. Okay. Thank you. That is all. Okay. Thank you. Bye.
My name is Mugilan. Today I'm going to present about CRC, which is an abbreviation for Cyclic Redundancy Check, which is used to correct errors, and it is normally used in LAN and WAN, local area network and wide area network. And before I proceed to the next slide, I want to recap about XOR, which is the inputs 00, 01, 10 and 11. What is the output for the input? And you also must know what is the data word and code word. What does that means? So this is the CRC encoder and decoder. As you guys can see here, the encoder has data word which consists of 4 bits, and it is added or increased by 3 bits. So the generator used the division process to divide the data word using 3 random bits, which is used as the divisor also as a random. The quotient will be discarded after the division. And as you can see, this is the encoder for sender, and this is the decoder for receiver. For the receiver side, there's a checker there. Checker is also considered as a generator, and it has a syndrome of 3 bits, and the 3 bits will be discarded as previous in sender also. So the division process will be happening in the next slide. So this is the division in CRC encoder. For the division, the divisor will be used, and this is the remainder, and the quotient will be discarded. And for the leftmost bit is used for the quotient. If the leftmost bit is 0, the 0 will be labeled on the quotient side. If the leftmost bit is 1 will be labeled as the quotient, and the remainder will be added to the code word. So thank you very much.